Taguchi, all these are quality gurus. So different way of explaining what is quality depend on who you are lah. You can be from manufacturer, or you can be from customer, or you can be from normal people in the society. Okay. So one interesting thing from Taguchi, he mentioned that quality is lost to society. Okay, lost to society. If we don't practice quality, actually it's a loss to society. Okay, kerugian to society lah. So we will look more deeper on that, what he meant by loss to society. Okay, so different way of saying this quality, degree of excellence. Ada kalau kita, if we go to, for example, if we go to hotel, for example, we classify through stars. Okay, university pun rating by stars. We have five stars, 6 stars. Okay, according to certain scheme of rating lah. So these are related to quality. Okay, and sometimes you also use this apa kita panggil ni? What do you call this? The yellow
emoji.
Emoji. Okay, so you also can give this rating. There are toilets in some places. They ask you to put a survey. For example, you go to airport. Okay, how satisfied you are as customer after using the toilet. Okay, so the rating is by pressing whether you are smiling or you are, you know, not happy and so on. Okay, these are expression of quality of services. Okay, dimension of quality. There are many ways of explaining quality in terms of performance, in terms of feature, conformance, reliability. All are these different angles of quality. So it means that quality is something that very broad. Okay, it can be in terms of performance. It could be in terms of aesthetic. It could be in terms of durability, reliability. So depend on what level of your usage of the product or service. Okay, I think all of you are familiar with this. Where do you see this symbol?
Food, tin makanan.
Tin makanan. Okay, Kak Maggie mungkin ada kau. Siapa yang suka makan Maggie tu cuba tengok ada tak mark pada Maggie. Okay, bukan saya galakkan makan Maggie. Maggie tak bagus. Tapi there are marks for food, okay, for products, for many items. So there are safety symbol. These are MS mark, meaning that Malaysian standard lah. Okay, that item has satisfied the minimum standard. Okay, ni ialah bentuk gasing lah. Okay, gasing that was used in Malaysia to indicate to the customer, to give confidence to customer that particular product has satisfied minimum standard for that particular product. Okay, so this refers to quality also. When we have standard, we refer to compliance to the product quality. Okay, there are many other symbols. You can see safety symbol, especially for electrical components. Okay, for 3-pin plug, contohnya, for example, 3-pin plug for light bulb, for some electrical, maybe rice cooker, you can check. There are safety marks. The shape is gasing also, the spinning, what do you call this, things. So it is to indicate that it has satisfied the testing and following minimum requirements set by the authority lah. In Malaysia, SIRIM is the authority on giving this symbol. Okay, so we have confidence in using that compared to a product without this symbol. So this is referring to quality. Okay, referring to quality.
Doktor. Kalau
Yes.
yang logo buatan Malaysia tu, yang tu ada kena mengena dengan kualiti tak?
Logo buatan Malaysia pada Wati
Maybe. Kalau ada kan.
Biskut. Buatan Malaysia is basically to show that this product is locally made lah. Okay, so it does not as stringent as what we put it in Malaysian standard. Malaysian standard, you have to satisfy, you have to test, must satisfy minimum requirement. But in the case of Okay, in the case of apa tadi, the case of buatan Malaysia ataupun apa tadi dia kata tadi? Dia panggil apa? Buatan Malaysia. Can you say again?
Ya doktor, yang logo tik tu, yang buatan Malaysia. 3 color tu.
Buatan Malaysia. It is not directly related to quality lah. It's just to show that this is Malaysian product. This is
Doktor,
Chinese
kalau
product.
simbol halal JAKIM kan dia ada audit ke apa quality
Yes.
atau tu kira ke?
Kalau halal, yes, halal is considered as one of the quality features. It's not listed dalam sini because this book that we learn, it is coming from West. They don't put it halal. So we can add one dimension of quality is halal. Okay, so I think it's very good that you raised that. Halal is one of the aspect of quality. Okay, we can put one of dimension of quality is halal. Okay, halal is you must satisfy minimum requirement. Halal is actually a standard. So when you are referring to a standard, it means that you are referring to quality. So to get halal symbol, it's not easy. The product, especially food products, you have to go through stringent inspection, okay, by qualified auditors lah. Okay, in terms of the processing, in terms of material, in terms of handling, okay. So to ensure that it is halal, halal bersih dan halal lah. Apa dia panggil tu in Arabic dia panggil apa? Halal and tayyibah apa?
Halal dan thayyiban.
Tayyiban, yes. So it is quality, related to quality, okay? Because it's following standards, okay? So, okay, any more question? Right, so this is what we call it Kano model. I put his photo there so that you can remember. This is the person from Japanese. He introduced this Kano model. What we call it must be quality and attractive quality. Okay, what you can understand from this graph? You can have horizontal line is degree of availability. Okay, you can see a degree of availability here. Okay, on this side is customer satisfaction. Okay, so normally as a basic, must be quality, must be satisfied. Okay, but what the customer will be very happy if when you put here attractive quality. Okay, unexpected, something unexpected, but you deliver to customer. Okay, so if we are just satisfying here, okay, so the customer just satisfied and then no complaint lah. But at this part attractive, this is the wow factor lah. Okay, so this is something that many manufacturer and supplier ataupun service provider, they try to find out what is actually attractive to customer. Okay, customer also do not know what actually this. Okay, something hidden. Suddenly they say, wow, okay, we never expect, but we got it. We very happy. So this is what we want to find. Okay, what a wow factor, so that customer will be very happy. Okay, they will spread the good news about the product and the service, and they come back again. Okay, return to get the services. Okay, this is another way of putting it of the same diagram. Okay, this is Kano diagram. Kano diagram. Okay, so what we say delighted. Okay, excited. Okay, didn't know I want it, but I like it. Okay, the customer say I didn't know that I want it, but suddenly it's given to you. You'll be going to be very happy. But on this side, cannot increase satisfaction, but can decrease it. What we call it must be quality. If not satisfied, the customer will be not decrease its satisfaction. All right. So we also discussed about TQM. Okay. So we explained this TQM, total quality management. Total quality management. So the responsibility of quality is everyone. Okay, if we look at the evolution of total quality, okay, evolution, maknanya how it evolved. Okay, I would like you to see this diagram. Okay, this diagram. Try to understand this diagram. Okay, how the quality paradigm have changed from operator quality control to total quality management. Okay, what happened in between? Okay, can you look into it and share with class what you can understand what happened in between? Okay, I give you about 2 minutes. Can you try to look into it? Boleh baca ke? Boleh nampak ke? I think if you are on computer,
Boleh
should be
ada.
okay.
Boleh je, boleh je.
Alright. But another person will do the inspection. Okay. So the movement is we have a foreman quality control. Okay, where the production quantity become increased. Operator only do the production and not responsible to operator solely responsible for production. Okay, where it is perform specialized tasks and not responsible to manufacture the entire products. So in this case is where we have we divide what we call it division of labor lah. Okay, division of labor. So like the case of making shirt just now, that tailor make the whole shirt. Okay, but when the quantity increase, so the shirt itself is divided. Okay, there will be maybe the bottom part is somebody else, putting the button is another person, putting the pocket is another person. So the job has been divided. Okay, why? When we divide like that, the productivity increase. Okay, productivity increase. The purpose is to reduce the cost per unit when we divide what we call it a division of labor. Okay, we divide tasks to smaller pieces, which is easier and faster. And then the practice of quality move to inspector quality control. So his job is only to do the inspection. Okay. Product demand keep increasing, manufacturing become complex, and foreman is responsible for multiple and hence getting more involved in administrative function. Okay, the foreman getting more job, he also do the planning and other things. So he does not have enough time to take care the whole production. Okay, so when the manufacturing keep increasing, quantity becoming more, okay, we implement statistical quality control. Why? It is not possible to inspect every single pieces. Okay, so inspection function become too big. Okay, especially for large quantity of production. Inspection become very big, not possible to do inspection one by one. So this is where sampling is being introduced. Okay, we use sample. We just take sample, and based on sample, we make decision for the whole production. So there will be a risk. Okay, risk when we are taking sample. Sometimes we make wrong decision because of the sampling test giving wrong answer. Okay, and then coming to the evolution of TQC. Okay, before you got TQM, TQC was before that lah. Okay, so C here is control. Okay, so understanding of the process was improved, but quite often recommendation quality improvement could not be entirely implemented. Okay, so this is where the quality strategy at the bottom here. Responsibility for quality to the engineer, supplier, management, and other related. So this is the first time that total is coming into the quality. Before that, it's only SQC. Okay. So and then move to TQM. Okay, total quality management. Okay, so where you have top management are committed to be responsible for quality issues, not only the production. If you see here, these are production. Okay, all these are shop floor, shop floor, inspector in the shop floor. The quality also related to still in the production line. So when we have TQM, so now the management take responsibility. So nowadays, we see that there are some changes still happening. So what we call it technocraft quality. Okay, maybe the term is not so popular, but actually more technology coming to the role of quality. Okay, we want it zero defect, for example. Okay, faultless execution. So there are new terms coming. New terms coming. For example, now we heard about Industrial Revolution 4.0. Okay. Okay. So in line with this, we also have Quality 4.0. Okay. So Industry 4.0, okay, which is where automation, cyber, physical, internet, real-time monitoring, okay, sensors, IoT are used. So where the integration of sensors, devices, equipment get connected through internet. So more focus of Industry 4.0 with respect to quality. Okay, some scholars, okay, some scientists are referring this as Quality 4.0. Okay, where we have technology. Okay, we embed technology to the function of quality. So quality generate a lot of data. Okay, quality generate a lot of measurement, testing data and so on. Decision has to be made. So those involved in quality will be very powerful if they also learn about data analytics, for example, data analytics, because you need to analyze data to know where is the problem. Okay, the problem with the machine, the problem with the products, and so on. Okay, so so this is a new frontier paradigm in the quality. So basically what we want is try to customize the quality. Okay, try to customize the quality. If you see that quality was customized at the beginning, okay, this is where the operator quality control. Okay, so actually the customer like to have customized quality. Okay, so it is not possible to practice like the old days that no one operator or one teller will produce one shirt. It's possible, but it's very expensive. Okay, so what we want is we use technology, we use intelligent system, robotic, flexible equipment, and so on to customize to the need of customer. So again, customization in the quality is possible, but with intelligence and automation. Okay, so we see that we go back to the original beginning of the quality, where it is customized and is tailor-made. Okay, any question on that? Okay, I move on that quality is responsibility of everyone. Okay, everyone is responsible in the organization, coming from marketing, design, procurement. Procurement is related to purchasing, purchasing material, raw material, parts and component, and so on. Process, production, inspection, packaging, and so on. Okay, in the past, these are quality, inspection, monitoring of the do the inspection, testing, and so on. But now, not only that, everyone are responsible. Okay, because if he purchase this procurement purchase poor substandard quality of material, so everyone will suffer. Okay, so if the design have produced poor design, everyone will suffer. Okay, production not producing according to spec also create a problem. Okay, and so on. So okay, so in quality we are comparing in terms of quality, delivery, and price. Okay, this is where competition in IE, we are normally referring to quality. Delivery is related to time. Okay, and the price is related to cost. Okay, so I mentioned this many times already. We are competing in terms of quality. We compete in terms of time of delivery. We compete in terms of cost. Okay. So I think the rest you can read on your own on this part. Okay. All right. So this is what we call this some component of TQM. TQM is concerned about customer focus, employee involvement. So everyone should be involved. And our concern is to satisfy the customer. Okay. And TQM also related to process, okay, improving the process to prevent producing defect product. Okay, we want to prevent. We don't want to produce bad product and busy do the inspection. Preventive is better than cure. Prevent. So how do we prevent? By having good machine, good operator, good design. So we produce right the first time. Okay, we reduce the need of repairing, rework, and so on. Okay, continuous improvement. So this is another element or component of TQM. Okay, continuous improve. Okay, we improve today. So in the future, we're also continuing looking for opportunity for improvement. Okay, continuous improvement, customer focus, employee involvement, process center. Okay, these are the key ingredient lah in TQM. The others are the supporting lah, the communication, decision making based on facts, strategic and integrated system. Okay, so maybe you are wondering, okay, how we can differentiate between quality control, statistical quality control. Okay, so different terms are being used. Okay, you have quality control. The sub inside of quality control is we call it statistical quality control. Okay, this is statistical, where statistical techniques are used for analyzing data. Okay, to guide us in making decision. Okay, statistics is useful in quality. So, and then statistical process control is one of the major component in SQC lah. And another part is sampling. Okay, so these are involved with data analysis. What is quality assurance? Okay, we also sometimes heard about quality assurance. So quality assurance is systematic action to provide adequate confidence. Okay, we provide confidence. Okay, keyakinan, level of confidence. Product or service will satisfy given requirement for quality. Okay, quality assurance is giving the confidence. So QA department does not responsible for quality, but responsible to evaluate the effectiveness of total quality system. Okay, so it determine quality problem areas and assist in correction, cooperate with respondents. So this is like he is ensuring. This is like auditing lah. Okay, quality audit. When you do quality, there will be another independent party doing the audit on quality. Okay, he is checking whether the system being implemented or not. Okay, is it something that is deviate or not properly monitored? Okay, we have inspector, so we have to check the inspector whether he is doing his job properly or not. Okay, so we have to check even the inspector. So somebody else is ensuring, okay, to give the assurance, okay, that the job of quality is being properly implemented. So there will be assurance there. So he's not responsible for directly on the quality, but he is ensure that activities of quality is being followed as planned. It is like more on doing the auditing part, audit part. All right, I think this we have done that. Let me go to okay. Last time, okay, last class we have seen 7 basic tools, and I asked you to look into apa ni kita panggil cause and effect diagram. Okay, cause and effect diagram and also flow chart. Can I invite any one of you to volunteer to share so that we can see whether you get it correct or wrong? If not, I will call a name. Anyone want to volunteer sharing? Ada tak? Okay, kalau tak ada, okay, can I call Abdul Rahman? Kenapa left? Ada masalah internet ke? Okay, Zuhair. Okay, boleh share tak apa yang you dapat?
Boleh tak?
Okay, bagus. Okay, salah tak apa. We just want to see,
Betul. Ya.
Yeah. Okay. This is flowchart, right? Okay. Kenapa hilang pula?
Kejap tu. Saya ni ya. Saya share entire screen lah. Ya. Okay.
Okay.
Okay lah. Ya, saya. So, orang contohnya this morning. Okay. So, yang ni untuk saya cari flowchart untuk COVID-19 punya testing.
Okay.
So this is the flowchart for the COVID-19 testing. So, firstly, if the individual has experiencing these types of symptoms, for example, like fever, coughing, or shortness of breath, and then he or she has to refer to a physician, and then the physician will recommend that individual to a doctor, and then the doctor will advise the person to come into his office, and then he will do a swab test. He will do a swab test for the
Sorry. Can you zoom in a little bit?
Okay, ya,
Sorry.
Tahu. Ya, saya nampak ke? Okay.
Okay.
Alright.
Boleh besar sikit kok, kawan tak nampak tu.
Besar sikit lagi ya.
Okay.
Okay. Okay. So balik pada tadi. The doctor will advise the person to come in, and then he will collect the specimen, and the doctor will do a swab test, and then he will send the specimen to a lab to be tested, and then he should have the result within 24 hours. After he has done the swab test, the doctor will identify the symptom that the individual have, and then he will look onto this criteria and identify whether the individual has a mild symptom or a severe symptom. If he or she has a mild symptom, the doctor will advise him to undergo a home isolation or quarantine at home. No need to go to the hospital. However, if he experiencing like a severe symptom, for example, like he can't breathe or he have a severe heartache, severe pain in chest, and then he will ask him to get an emergency help or to get a local urgent care. So yeah, this is for the flowchart. Then okay, and then we go down to the fishbone or the Ishikawa diagram. So this is for the wrong. The cause is from the wrong, the delayed or damaged delivery, and then this is the cause. So this is the effect. This is the effect. The wrong or delay or damaged delivery. This is the cause, which contribute to this effect. So the cost is material. The main cost is material, method, machine, environment, measurement, and the personnel. So for the material punya cost, if the cargo agency use a wrong packaging material for a fragile product such as glass, so that will not be good, is because that if he or she are doing a delivery and then the package fall, it will easily damage the quality of the package, the
Okay.
quality of the product. Yes, it's because
Okay,
it's
Zohair,
fragile. Yeah. And then
okay. Zohair, okay, stop there.
okay.
Okay, I think overall it's very good diagram lah. You tunjuk tadi.
Oh,
Tunjuk
okay,
tadi.
sir.
Okay, overall is good. The only thing that you need to improve, here. Is you can, okay, let me do this
Okay.
annotation.
Right.
Okay, if you can improve this arrow, it should go inside,
Okay. Alright.
direction here to, and then all the arrow go in, go in.
Okay.
Semua yang lain-lain pun sama, So dari segi classification, okay, material, machine, method, okay. So this is normally, sometimes we call it 4M lah. So the another M will be, sometimes people use it for measurement, okay. So man also can, personnel is man lah, okay. Environment. So the classification, so you have major class. This is major class, okay, major class. So this is minor lah, what we call it cost. This side is cost, okay. And this side is effect lah, cost and effect, cost and effect. So what you do is correct. Only thing is to improve dari segi dia punya nak mana ni lah, arrow ke mana. So ni pun arrow ni sepatutnya ke dalam, ke dalam. So you have major cost, yang kat luar ni major cost, and the one is inside. The major cost is minor cost lah, supporting to the major cost. Okay. So right, can you move on to go back to your flow chart?
Okay. Saya.
Sir, untuk dia punya bone shape tu, dia mesti
Yeah.
arrow kalau tak arrow tak boleh.
Normally people use arrow to show where it is going.
Okay.
So if you don't have arrow, we don't know the flow of that. Dia what do you call it? Dia moving to which direction. Okay, normally arrow lah we put it. If you don't put arrow, boleh juga, but having arrow it is better lah. Okay, that's normally. Okay, commonly practice they put arrow. Okay, on this. Okay, can someone comment how we can improve this? Okay, I think it's good to have a flow chart. You are converting now, instead of describe what to do, but now we put it in diagram. Especially engineers, we like to see diagram, flow chart. These are the tools of engineers to communicate with others. Okay, so we like to use flow chart. We like to put things in, in a clear way. How we move from one step to another step. So I would like to ask the class, okay, how can we improve this? Okay, Khairil, you're there. How can we improve this? This diagram.
We can change it to the symbol like square, circle, triangle, arrow, and the D shape.
Okay, so one way to improve is we can use standard symbol. So because from this symbol, not to say it is wrong, it is okay in general. If you go to many places, some of the non-industrial engineering, they just use what we call square like this. They just use square like this. But the problem is we don't know which one is operation. We don't know which part is delay, which part is inspection, which part is value added, which part is non-value added. We don't know. Okay, if we use industrial engineering symbol, okay, let me show with you here. Industrial engineering symbol, we know what is actually happening. For example, this is operation. Yeah, a circle is operation. Operations mean, okay, you are changing the value added. Value added is given. Value added is given to the process. Okay, so when there is inspection by doctor doing the swab test, we can use the symbol like this. This is inspection. Okay, so when there is a movement from one point to another point, we can put it arrow like this. So we know that movement, we can analyze how many movement happening. Is it this movement can be reduced or can be eliminated or how? No, if there is waiting, we can put it delay like this. Okay, delay. If after doing, especially for material, when finished, we put it in store, we can put it inverted triangle like this. So when we represent the activities using the symbol, we can improve it, okay? Because our purpose is we want to minimize, okay? Minimize the traveling. We want to minimize the waiting, okay? So because these are non-value added, okay? Kita kata tak ada nilai tambahan. One is nilai tambahan berlaku, value added when this operation happening. Even inspection pun, there is no value added. We need to minimize this. But sometimes not possible to eliminate, okay? But we can minimize, okay? So waiting, transportation, we can minimize to make it efficient and faster, okay, more productive and so on. All right, thank you very much, Zoe, for sharing. All right.
Thank you, Doctor.
Yeah, I will move on to look at other method. Okay, we have not discussed about Pareto. Okay, let me share with you Pareto. Okay, boleh nampak
Boleh, Doctor.
Okay, so what do you see on the screen?
Basic SPC tools.
All right. Basic SPC tools. Okay. Okay, I want to share with you this Pareto. Pareto. Okay, what do you see this Pareto? How it looks like? It looks like a bar chart, right? Okay. Pareto is just bar chart. The only difference is it is arranged in descending order. Okay. The highest will be on the left. The smallest will be on the right. Okay. So this is bar chart only. Okay. So okay, this is a example of this. Also, we can have in Pareto. Pareto actually is coming from a name, okay, of one of the scholar previously lah. He introduced this. So the concept of Pareto is coming from what we call it. We have a lot of information, a lot of classification, but actually we have a lot of trivial items which is not significant, but very few which are vital, very few which are very important, but there are many things which are not important. So Pareto is actually for prioritize. Okay, we use Pareto to prioritize, memberi keutamaan, priority, prioritize. We want to prioritize, for example, type of defects. Okay, for example, you may have different type of defect. A may be broken. This is maybe small hole. This is maybe C may be scratches. So this may be mislabel and so on. So those who are category A is considered as our priority to solve the problem. Okay, Pareto chart. also have this line, but we call it cumulative line. This is cumulative line. We have cumulative line. Okay, cumulative line. Cumulative line to show that how it's increasing. How it's increasing. So if we have a line like this, we see that there is higher increment here, but it will slow down after that. Okay, because the number decreasing. So this concept of Pareto sometimes referred to as 80-20 rules. Okay, 80-20 rules. Okay, so what it says that 80% of the problem is contributed by 20% of the causes. Okay, so like here, we can say that majority of the problem is contributed by A and B only. Okay, majority is contributed by A and B. So if we can solve A and B, we can say roughly 80% of the problem can be resolved. Okay, the others is only 20%. 20%. So you may have more classes here, which is not many. So we can remove this. This is contributing to 20%. So another way to put it, this example, we can say that okay, the wealth, okay, kekayaan, 80% of the wealth in society is belong to only 20% of people. Boleh faham? So dalam satu masyarakat, let's say you have 100 people, 100%. Okay, out of these 100, okay, majoritinya adalah wealthy or poor people ataupun average people. Majoriti orang lah. Majoritinya kaya ke miskin ataupun sederhana. Can someone respond? Okay.
Sederhana, Doktor.
Ya, Doktor.
Okay, say again. I want
Sederhana.
Sederhana, okay. Sederhana dan miskin lah, kebanyakan. But very few people are very rich, right? So these very rich people, okay, the number is what? It is large or small? Very rich people.
Very small, Doktor.
Very small.
Doctor.
Very small. Okay, very small people, they are very rich, but they own 80% of the wealth. Okay, harta dia punya 80% dia punya. Tapi bilangan orangnya sedikit. So this is concept of Pareto. Okay, concept of Pareto. So especially in countries, developing countries, poor countries, this is what happening. The wealth is belong to very few people. Okay, not fairly distributed lah, but majority of people are poor. Okay, 80% of people are poor. The rich one is maybe 20% for some countries lah. Okay, but as the country is moving, develop and so on, okay, we get more people getting rich and the wealth is more fairly distributed. Okay, the concept Pareto say the same thing. So, and the same concept is being used to describe works in organization. If you have 100 people working in a company, so concept of Pareto say that those who really work is only 20%. This 20% of ataupun out of 100, 20 staff lah, 20 staff. These people are really do the work. Okay, the balance 80%, they just do very little. Okay, so they might be doing only 20% of the work. Maybe in the past lah, maybe now, maybe I think this is not happening lah. In the past, this is what happening. So 80% of the people, they do very little. They just go to work, okay? They just sembang sana, sembang sini, pergi minum kopi dan sebagainya, pukul 4, pukul 5 balik. Okay, they just do 20% of the work. Okay, that was in the past. So this is concept Pareto. Okay, so the same concept is used in quality. Why? We want to prioritize our effort in solving quality problem. it is not possible for us to solve all the problem at one go. Okay, we need to prioritize. Why? We have limited man hours, we have limited workers, we have limited inspectors. So we prioritize based on concept of Pareto. Okay, what is Pareto? Pareto is the law of how to prioritize. Okay, mencari keutamaan. Okay, so this is in the word, it's saying that 80% of the process defect arise from 20% of the issues. Okay, the cost is 20%, penyebabnya 20%, but contribute in terms of quantity 80% of the problem. Okay, so it apply in many areas also. So what we do is in preparing the Pareto diagram, we have to rank the data in descending order. Okay, descending order, meaning that highest on the left, and then we move down. So this is what descending order. Okay. Pareto diagram I use to identify most important problem. Okay, most important problem. So the most important is this one. If we put this in this Pareto, we know what is the most important problem. We tackle the most important. It's not possible to us to address all the problem. If we address the important one, we are actually solving 80% of the problem. Okay, that's the beauty of it. Okay, Pareto also provide visual explanation of this. Okay, so all the effort are directed to the what we call it vital few. Okay, vital few, meaning that the critical one is very little, very few, vital few. Trivia, it is small, the small problem is many. Yeah, many small problem. So don't waste our time to solve trivial problem, but we focus on the key problem. Okay, so that majority of problem will be solved. So the step are there. I think you can read on your own there. Okay, in doing this, okay, this is also example here, Pareto. Sometimes we can have in Pareto, you can have the last one is higher than the others. Something like this, for example. You may have a graph like this at the end. This is what we call it miscellaneous, where we add all the small causes to the last one. So you may have the last one is higher than, for example, if you have so many small of this, maybe you add all this and make it as one here. So it might have higher. But the others is just following descending order. But don't put miscellaneous, somewhere at the beginning, because it's not correct. Miscellaneous means the addition of smaller causes, you add and you put to the last one. Okay. So normally we come together with this cumulative line. If in terms of frequency you have 300 here, but in terms of cumulative you will have 100 here. So we can see that if we want to achieve 80%, so we can say that 80% of the problem are belonging to this three category. Okay, so we solve this problem. Okay, so depend on the style of doing, you can start 0 here, or you can start 0 here. Okay, not 0. This is representing about 38%. Okay, for this part, 38%, because you are following this on the left side, the scale on the left. The second one is the cumulative of this, 38 plus 37, you get 75. Okay, somewhere here, 75. Okay, continue. So you get one is in terms of numbers, one is in terms of percentage. Okay. Okay, the bottom part here is the classes of the problem. All right, so this one you can try your own. Okay, we have these values here, and prepare a Pareto diagram based on these values. Okay, so this is also another example. You can try your own. Okay, so but one thing I would like to remind you here, when we put Pareto, you can have here in terms of frequency, in terms of unit. Okay, And also you can have, sometimes you can have, of course here is the type of problem lah. This is type of problem. Type of problem. Okay, type of problem. For example, you have, okay, depending on okay, for example, you may have, this is type, not necessarily ABC, maybe here is E. E is the highest, for example, okay, because you have to reorder again. Here maybe A is here. Okay, I just give randomly the label. Maybe you have here is B, for example. Okay, and so on. So on, you continue that. But remember, this is in terms of frequency, in terms of units, number of units. But if you convert this into money, the frequency may change, because sometimes the problem here is many, but the amount of money, the cost of repairing is very cheap. Okay, so you may also have plot in terms of cost, the cost, repair cost, for example. Okay, if you are analyzing defects of products in manufacturing, okay, so maybe the cost of E is maybe only 50 cents to repair. Okay, even it is high, but when you multiply with the quantity, it may not be the priority to solve this problem because it's so cheap. But if, for example, here you get it, let's say D here, but to repair this, the cost is expensive. Okay, for example, the D, the cost of repairing of D costs $10 per unit, for example. Okay, maybe it's not many, but at the end, maybe D will become the most important here in terms of money. Okay, in terms of money. So we need to be careful. Either we are giving priority to eliminate the in terms of unit or in terms of money. Okay, so maybe when we put like this, maybe at the end we get it, E is here, for example. So E is no longer the main, because in terms of money, okay, because it's very cheap. So the order can change because of the value of repair. Okay, repair cost. So if the money is very important for the company, our decision making based on where we lost, okay, we lose money for which type of defects. Okay, that is the priority. Okay, if it is so cheap to repair, but the number of the defect is so many, so it's not going to be the priority for solving the problem. The solving of the problem will be where we lose the highest money. Okay, so in terms of unit here or in terms of money. Okay, we have to be careful. Depend on question. Sometimes question asks us to get the maximum profit, so we have to use the cost of repair as the criteria for giving priority. Okay, I have discussed this. Okay, some of you asked just now whether you need to use arrow or not. So some diagram do not have arrow, but it's good to have arrow. Okay, especially we want to see the direction. Direction. But if there is no arrow, doesn't mean that it is totally wrong. It's not wrong, but it is nice to have arrow. For example, this one, we have this, okay, defect in PCB. Okay, so what are the category? Category here is, okay, or this part is the category here based on the process, component, insert. So even cost and effect diagram, there are many types. There are based on category of major cost, minor cost, and also sometimes based on key processes, okay, in related to the product. Also can. Okay, but what is important is we categorize anything related to shoulder here. Here solder, not soldier, ni solder ni. Solder. Okay, all are here. Related to cut, all are here. Okay, So when we put in the diagram like this, easy to understand, easy to understand. So these techniques are very popular, especially among Japanese. Japanese, they like to see diagram, figures, table. Okay, so this is also another example. You can also Google. I ask you to look at example. So I'm sure you have seen many of these. Okay, so this is also used for brainstorming. Brainstorming, we call it brainstorming. Cause and effect diagram is a brainstorming techniques. Okay. Sometimes people say brain selling. Okay, brainstorming. You get ideas, percambahan pikiran. Okay, you do brainstorming. So we summarize the brainstorming ideas into cause and effect diagram. Okay, so how to do it? There is a step there. Okay, so brainstorming is to get new ideas. Okay, so but it's not part of 7QC tools. I put it here for you to relate it. Okay, we can use brainstorming to generate fishbone or cause and effect diagram. Okay, so I think some of you might be familiar with this mind mapping. Okay, so actually cause and effect is similar. They have similarity with mind mapping. Mind mapping. So it is good to have mind mapping to summarize your note, because when you revise using mind map, is you can recall faster compared to you write a descriptive note. Okay, so this very powerful techniques. I'm sure that you have used it maybe during your study. Okay, develop mind. So just concept of cause and effect is just like mind mapping. All right, any question before I move to check sheet? Hello? Oh, you need a break now? 10 minutes? Yes or no?
Okay.
So we take 10-minute breaks and come back 12:15. Okay?
Good.
Okay. We try to think about this. So you have heard about Six Sigma. I mentioned about IR 4.0. Okay. So we try to see, is there any relationship or not? Six Sigma and 4.0. Okay. So I'm giving you a general explanation here to give some flavor to you, and also to create interest on Six Sigma and IR 4.0. We will go more detail later on with specific explanation of Six Sigma. Okay. So what is Six Sigma? What are key elements in this? Okay. So we start thinking, what is Six Sigma? Okay. So we are producing products. Okay, we are producing products. There will be not possible to produce exactly the same piece. Not possible. There will be variation. We have studied this. There will be variation of process and product. In product also variation. In terms of process also will have variation. Okay. So this variation is explained in terms of when we put it in bar chart. Okay, we plot histogram. You remember that last time I asked you to plot the weight and height, and okay, so this is variation. There will be variation. We are not the same. Okay, of course, different parents, different mother produce different weight and height. Okay, even same brother and sister pun not the same. There will be variation. So the same analogy, if we say that it's coming from same machine, but it's not going to be exactly the same. There will be variation. So we explain this variation in terms of mean and standard deviation. Okay, mean and standard deviation. So if we plot it in terms of this target, in terms of what we call the accuracy and precision, here we can have a situation that this is very good, this is very precise and accurate. Precise and accurate. But there are situations that is not precise and it is not accurate. Okay, not precise, not accurate. So this situation lah. Okay, this situation not precise, not accurate. Okay, but this one is accurate but not precise. This one is precise but not accurate. Okay, maknanya dia miss the target lah, miss the target. So this is how to describe the variation lah. We have variation, how to describe variation. So what we want is accurate and precise. Okay, accurate ni maknanya dia be on the target. The target is in the middle lah. So this is our target. Okay, we want it, if possible, every time we produce must produce at this target, but not possible because of variation. Okay, so sometime if this is shifted to here, we already off target lah. Maybe the product is repeating on the same here. Maybe go to like this. Okay, they're off target lah. So we need to bring this, reset balik to go to the original position. Okay, so we already study a bigger standard deviation also no good because it is not precise. Okay, not precise. Dispersion is very high. Okay, this is how we describe variation lah. Right. Okay, so before we understand sigma, we need to understand the sigma level. Okay, you have seen this before, kan? Okay, so the sigma, if we say plus minus 1 sigma, we are covering 60%. Okay, we say plus minus 1 sigma, we are referring to 68% under the curve, bell-shaped curve. If we say plus minus 2 sigma, we are covering 95%. Okay, 95% of production will be plus minus 2 sigma. But if we say plus minus 3 sigma, okay, plus minus 3 sigma, we are covering 99.7%. Okay, meaning that this area to this area. Okay, this point, from this point to this point. So almost, okay, all, but we have about 0.3% outside. Okay, 0.3% is outside here. Okay, outside here, 0.3%. 0.3% still outside, 3 outside. Okay, so if our production is plus minus 3 sigma, we are covering 99.7%. So assuming we are producing 1,000, or we are producing, let's say 100 unit, 100 unit. Out of 100 unit, 99.7 are good. Or maybe I put it 1,000 as well, 1,000 unit. So we have 99.7, 99. Okay. Sorry, 997. 997. Oh, lari, So if we have, if we have, okay, if we have 1,000, okay, if we have 1,000 unit, okay, 1,000 unit, we actually having 99,997. 997 are good. Only 3 unit are bad. Okay, only 3. Okay, so this is where we are having plus minus 3. Yeah, plus minus 3. Plus minus 3. But when we are talking about 6 sigma, okay, remember here, you have 3 sigma here and 3 sigma on this side. Okay, all together is 6 sigma. Okay, so when we say 6 sigma, we are referring 6 on the left and 6 on the right. Okay, all together it will be 12. 12. Okay, 12. So this is when we put it in this diagram. Okay, lower limit, upper limit. So if you have lower limit, upper limit, okay, so if this is 12 and this is your process, the yellow color, okay, so you are very far. Okay, you are very far from the limits. Okay, very far from limit. Okay, very far. So when we are having 6 sigma quality, you don't have to worry about inspection. Okay, because we are guarantee whatever we produce are good products. Okay, good product. As I mentioned earlier, most of the company, okay, they are operating at plus minus 3 only. Okay, plus minus 3. So most company that are operating at plus minus 3 sigma, meaning that they are here. Okay, they are here. Okay, and then when we are here, if control limit is also here, okay, if the control limit also here, okay, so we will have problem of producing bad products here. Okay, bad product here. So if we want to increase this to make it 6 sigma, we have to make it thinner. Okay, so that this will be 6 sigma and this side will be 6 sigma. Okay, so the sigma value must be smaller lah. Maknanya smaller sigma value. Okay, when we have smaller sigma value, we can have what do you call it, a distance between these. So having the control limit shifted outside, no good sebenarnya. Okay, we can have 6 sigma there, but the sigma is big value. That is no good. So what we want is this one, the yellow color, but it's far from the control limit. We don't want that this one is this is 3 sigma here. This is 3 sigma. See here. This is 3 sigma. Okay, from here to here, 3 sigma. But the sigma here is big value. What we want here is like this, 6 sigma. Okay, we want it 6 sigma of this. Okay, 6 sigma of this, where the sigma value is small, so that we are far from the control limit. Okay, this is what we want. All right, if you understand that concept of 6 sigma, okay, so this is a method to improve capability of a business. The purpose is to increase process variation. Okay, also to reduce defect, improve profit, and so on. And also to increase the morale of the workers. When workers are not, bought down with defect products, they will be happier workers. So if we look at in control chart, if you look at from the control chart perspective, if this is high variability, after improvement, we can get lower variability. Okay, further improve until we can get a good, see there is small variability here, okay, in this part. Okay, this is where you use control chart, okay, to keep reducing the process variability. Okay, control chart. Okay, So another aspect that we can derive from here is, okay, we will study later what we call it process capability, process capability. Process capability index. Okay, process capability index. Okay, what we do is we have tolerance. Okay, process capability is tolerance divided by okay, what we call this Six Sigma, or we call it okay, let me put in simple term. It is control limits. Okay, the distance between control limits. Okay, control limits. Okay, control limit will be used when we discuss about control chart later on. Okay, control limits. Kenapa tak nak hilang ni? Okay, control limits. Control limit. Okay, so this is in, we can put it mathematically. Tolerance is normally it is upper control limit. Okay, upper control limit. So the upper spec limit. Okay, upper spec limit minus lower spec limit. Okay, that's tolerance. So we represent normally 4 sigma. Okay, 4 sigma and also 4 sigma on this side. So basically it's 8 sigma. Okay, 8 sigma. So when you are designer, you will use as a what we call defactor lah, defactor ataupun default value. Okay, we can use it 8 sigma. Okay, 8 sigma for the tolerance. Okay, what the sigma depend on specific case lah. What is the sigma? But generally we can say the tolerance is 8 sigma. Okay, divide by control limits. Okay, this is 6 sigma. Okay, because why? We have minus 3 on the left plus 3 on the right. So this will give us 8 sigma. So from here, what we get is 1.33. Okay, so this is the index that we use, okay, when we want to check the process, the process. So it is 1.33 is, we call it process capability index as a de facto values. Okay, CP, okay, ataupun process capability index equal to 1.33. So if we understand this, we can decide what should be the tolerance in our design. Okay, you study the design, you study design, you do tolerance. Okay, you put it, what is a plus minus value. So this will be the guide. Okay, what are the value to be put in the tolerance? Okay, based on capability of the equipment that you have in the factory. If you just randomly put the value, okay, so you may have problem with manufacturing engineers that are not able to produce as what you design. Okay, so as a guide, the tolerance should be 8 sigma, control limit should be 6 sigma. The ratio is 1.33. Okay, the ratio is 1.33. Okay, we will look into it more detail when we go to control chart and process capability. Yeah, so I'm giving you general understanding. Okay, now let's look at Six Sigma as a methodology. Okay, Six Sigma as problem-solving methodology. What I explained earlier was Six Sigma as statistics. Okay, Six Sigma in terms of statistics. I showed just now statistics. Okay, but now Six Sigma also refer to a philosophy for problem solving. Okay, Six Sigma is problem solving methodology. Okay, it's represented by what we call it D, M, A, I, C. Okay, this is a problem solving method. Okay, problem solving method. So Six Sigma is very popular. If you go to industry, even you Google, what are the job opportunities for Six Sigma experts? Okay, there are many openings, many companies are looking for those who understand what is Six Sigma. Because why? Six Sigma bring profit to the company because reduce process variation, increase quality, make a better product, okay, make a product is more preferable to the customer. So what they use, the method is, they call it, if you want to achieve Six Sigma statistics, but the method is, we call it DMIC. Okay, what is D? D is referring to define. Okay, D is refer to define, M is refer to measure, okay, A is analyze, I is improve, and C is control. So this is an extension of method, what we call it, if you familiar with what we call it, a method, we call it the problem solving method, PDCA. Have you heard about PDCA? Anyone? So, okay, somebody was saying yes. What is PDCA? What is PDCA? Can anyone share with me what is PDCA? It's also problem solving method. Hello?
Plan, do, check, Doctor.
Yes, plan, do, check, and act. Okay, plan, do, check, and act. So this is also popular. Okay, some people call it short PDCA. Some people call it, Deming. Depend on which side that you are referring, like what you are reading. So they also have the circle like this. Okay, PDCA. Okay, so before we solve any problem, we have to plan. We do implement our plan. We check the implementation. We add on it. Okay, PDCA. So it is like a cycle. But now what we have is we have define, okay, measure, analyze, okay, improve, and control. Okay, so it's also like a cycle, right? Okay, a cycle. Okay, a cycle. So PDCA is also problem solving method. So this method, okay, it was introduced in Motorola. Motorola, I think you know Motorola, it's an electronics company. Okay, Motorola engineers, okay, introduced this Six Sigma methodology. Okay, so okay. Okay, I will go in detail later on different, what is D, what is M, I, and C. So, but in general, we can see that the Six Sigma methodology are divided into two. Okay, divided into two. So this is this part, where we are solving, okay, the operational problem, okay. So we define, we measure, we analyze, we improve and control. So what we do is continuous improvement, okay, continuous improvement. Like in TQM also have continuous improvement. On the right side, we have DMADV, okay, DMADV, where the D here is design and validate. Okay, this is for more on design. Using design, Six Sigma for design, for example, using Six Sigma for design. Okay, so this is where you use define, measure, analyze, design, and verify. Okay, design, verify, where the Six Sigma is used for design. But in this one is Six Sigma is used for continuous improvement, operational improvement. Okay, so Six Sigma has been very powerful and proven in many organizations, and it has also integrated with other method. Okay, it has been integrated with other method. For example, Toyota. Okay, Toyota is popular for lean. Okay, lean manufacturing, lean system. Okay, lean system. Okay, Six Sigma is introduced by Motorola. Okay, all these are big companies, big companies. So now, if you go for Six Sigma training, you can get yellow belt, okay, green belt, black belt. Okay, black belt hebat lah, hebat. Kalau you can get black belt, so you can be a champion of Six Sigma in the company. Okay. So when Six Sigma joining with Lean, okay, new terms coming. They call it Lean Six Sigma. Lean Six Sigma. Okay, Lean Six Sigma. Okay, so what is the difference here? The Lean is to reduce the waste. Okay, it is promoted by Toyota, but Motorola is go more on Six Sigma to reduce the variation. Okay, to reduce the variation. To make the blue color here become green. Okay, which is lebih kurus lah. Okay, reduce the fat. So when you are reducing the waste and you reduce the variation, the company performance are very competitive lah. Okay, very competitive. Okay, so this just to give you the idea that how useful is the Six Sigma. Okay, so like the Toyota system, okay, they are more on focusing how to reduce the waste. For example, overproduction. Why we produce waste? Because it is we do not have a good prediction. We produce more than needed, so additional item has to be put in store. So this is what Toyota don't like to have it. Okay, we have to reduce the waste. Why? We want to sell the product at cheaper price. Overproduction is costly. Okay, over-processing also costly. Transportation, unnecessary transportation also unnecessary is a waste. Inventory is also a waste. Motion, unnecessary motion is a waste. Waiting also a waste. Okay, so the waste, this is referring to skill, lack of skill, for example, wrong skill. Defects also a waste. So Toyota focusing on reducing the waste, Motorola focusing on reducing the variability. So getting this together, we call it Lean Six Sigma. Okay, I will explain later how this can come back to joining with new development in industry. What we call it, what we call this industry 4.0. Okay, industry 4.0. Okay, so not only joining with Lean, but now Six Sigma is facing another development of 4.0. Okay, 4.0. I think you have heard about this industry 4.0, right? Hello,
Yes.
what is industry 4.0?
IoT. Internet of
IoT,
Things.
Internet of Things.
Yes.
So all these are digitalization. Digitalization. You see now there are a lot of things changing now. Digitalization. So we have to be careful. We have to be aware what's happening. Because maybe what we learn today in next 10 years or next 5 years maybe not relevant. Okay, we have to see many things are now digitalization. So it's important that engineers understand the digital, the computer, the computing, So it is coming from mechanization. This is industry 1. Okay, mechanization, water power, steam power. That was where conversion of manual method become mechanical, mechanized. The industry 2.0 is where the mass production, the assembly line becoming common, usage of electricity, where we produce more quantity. We need to have assembly line. Because assembly line, when we have assembly line, we divide the labor to specialized tasks. The unit cost will be cheaper when we produce high quantity product in a production line compared to have a customized product. At the beginning, before break, just now we mentioned about customized product. It's expensive, so it's better to produce mass produce. Like you buy your T-shirt, you buy your shoes, you buy your necessities in your house, a rice cooker. All these are mass produced. When they mass produce, we don't even know who will buy. We just predict who will be the buyer. That's why the production of shirt, for example, you have size S, size M, size L. We go to the shop and we select which one is fit to us. But those shirt was produced, mass produced. The manufacturer of shirt never know that you will buy the shirt. They just make prediction. So this is where the industry 2.0, mass production using assembly line. And then the revolution of computer and automation generate industry 3.0. Automation. We are able to automate with, because we have knowledge of controls, PLC, programming, and so on. But during this time, automated are not connected to internet. They are just connecting, within the job shop, within the factory alone. So yes, efficiency has improved, less manpower is used, but automation is remotely within that company. They are not linked to cyberspace. So fourth industrial revolution is talking about internet. Now machine and equipment are connected to internet. That's why you have Internet of Things. You have IoT. You have cyber physical. We are connected to the cyberspace. So we are talking about artificial intelligence. We are talking here now manufacturing, having smart factory. You have a smart factory. We have a machine. We have a machine who are able to inform the operator that something need to be changed. Without human go and check. There are equipment that are communicating between equipment 1 and equipment 2. This is the era that we are having now. Fourth, what we call it, industry 4.0. Anyone want to ask question just now? So now where is Six Sigma now? Six Sigma, where is it? So it seems that now we are overtaken by 4.0, digitalization. Is it a role for Six Sigma? Hello? What is the role of Six Sigma? Are we still relevant?
Yeah.
How?
Making sure the infrastructure between the internet and the machine works.
Works, okay. So I will leave it there for now, okay. So throughout this course, somehow we need to answer that. Where is Six Sigma in the era of 4.0? Okay, I leave that as open question for you to think, okay, until at the end of semester. Where is Six Sigma? Are still useful or not? Six Sigma, because now things are getting digital now. Okay, we see robot, we see intelligent machine, we see smart factory. Okay, we see that machine are connected to internet. You can do your design at your house, but at the end you send it through cloud, and your design is being, used by another engineer at another location. Okay, so I throw you this question, and okay, let me stop there, and okay, I close this one. Okay, so I want to go back to this. Okay, this is we're going to focus more detail on DMIC problem solving. Okay, so okay, this coming Wednesday, I think UTM has given flexibility here. There is no class because of those who are celebrating Deepavali. So now we need to replace this again. I owe you already 2 hours, and we need to replace again another 1 hour for those who are, want to go and celebrate Deepavali. How many of you are celebrating Deepavali in this class? Anyone? Hello?
If not celebrating but we need to balik kampung, how, Doktor?
Nak balik kampung, saya tak tahu. You kena minta kebenaran. You have to ask. You are in campus or?
No, I mean on that day we are not celebrating Deepavali but we balik kampung on that time. On that day,
Balik
Wednesday.
kampung. You are on campus ke dekat rumah? Kalau dah kat rumah nak balik kat mana lagi?
I
Holiday.
yes, Doktor, holiday. Long time.
Holiday. Okay. I think a few of you are celebrating. I think in this class, right? We have a few our friend celebrating. Yes or no? Okay. If that case, we need to have a replacement. So can we replace? I need to chat with you. Majority of you, when you will be free.